Finisar is a global technology leader of fiber optic subsystems and components that enable high-speed communications for networking, storage, wireless, and cable TV applications. Finisar's 40G line-side modules, including the first-to-market DPSK 300-pin transponder, deliver state-of-the-art performance while maintaining design simplicity. The modules operate without complex switchable or VOA-assisted demodulation techniques. Finisar's wavelength selective switch platform is based on liquid crystal on silicon technology. Compared to other switching technologies such as MEMS or liquid crystal, Finisar's LCOS WSS platform is highly software programmable, enabling a product that is field configurable and easily upgradable. In addition, LCOS technology enables advanced functionality in Finisar's WSS modules, such as high port count 50 GHz channel spacing, mixed channel plans for simultaneous 50 and 100 GHz traffic, drop and continue mode for broadcast applications, and channel contouring. As the only integrated supplier of high-speed 40 gigabit per second transponders and wavelength selective switches, Finisar is uniquely positioned to understand the needs of next-generation optical communication systems and to offer optical subsystems designed and tested to work together. To ensure interoperability of its products, Finisar has implemented a multi-wavelength recirculating loop operating at 40 gigabits per second. This testbed is used for evaluating and demonstrating product performance in a range of real-world optical networking applications. In particular, the impact of system impairments and component performance on different signal formats can be determined. Questions such as how many cascaded WSSs can be used before optical regeneration is required and what is the corresponding link length of that system can be answered. This is especially important in 40 gigabits per second networks where the impact of channel narrowing and any interchannel nonlinear effects are most prevalent.
The loop comprises an array of Finisar 40G and 10G DWDM transponders multiplexed together through Finisar's wavelength selective switches or WSSs. The resulting DWDM spectrum is amplified and launched through an optical switch into the recirculating loop. Two wavelength selective switches are configured as add and drop, allow any DWDM wavelength to be coupled out to an optical receiver. The WSSs are followed by an optical amplifier, an 80-kilometer fiber span, and an additional amplifier with mid-stage dispersion compensation. The DWDM signals continuously circulate in the loop with a fraction taped out after each lap until the loop switch is opened. The bit error rate tester, or BERT, is operated in a gated mode to allow measurement of system performance after each circulation of the loop.
In this video, we show how the loop is used to ensure performance and interoperability between Finisar's 40 gig transponders developed here in Israel and wavelength selective switches developed in Sydney, Australia. First, we demonstrate the performance of Finisar's enhanced 40G DPSK or eDPSK transponders operating at 40 gigabits per second with 50 GHz channel spacing transmitted through Finisar's liquid crystal on silicon-based WSS. eDPSK optimizes the optical performance of the transceiver by narrowing the transmitted power spectrum and maximizing the power in the center of the signal spectrum. The receiver design is similarly optimized to match the transmitted signal. This improves OSNR tolerance over all effective filter bandwidth range compared to other advanced DPSK technologies. Let's look at the performance of a single 40 gig eDPSK signal transmitted multiple times around the loop and propagated through multiple wavelength selective switches and fiber spans. As we increase the number of times the signal passes around the loop and increase the fiber length and number of passes through the WSS, we can show that the bit error rate approached the FEC limit of 10 to the minus 3 after 1600 kilometers and 40 cascaded WSSs. When comparing the waterfall curves after a transmission experiment, we find a 2 dB penalty compared to the back-to-back response after 800 kilometers of fiber length and passing through 20 WSS filters.
Our recirculating loop, however, allows us to simulate a real system in which there are multiple channels and modulation format present.
As a worst-case example, 40G eDPSK signals and 10G NRZ signals were propagated through the loop in adjacent channels with 50 GHz channel spacing as seen in this spectrum. These are the 40G DPSK channels and these are the 10G channels. In this case, the system penalty due to 3 adjacent DPSK channels is 1 dB. Replacing the adjacent 40G channels with 10G NRZ channels, the nonlinear XPM penalty was increased by only 0.4 dB. The low impact of the XPM is due to the combined effect of the eDPSK design and broad spectral passband of the WSS. When increasing the number of channels, performances are maintained as effect is mainly due to the adjacent channels. While eDPSK provides excellent transmission performance, other modulation formats such as RZ-DQ-PSK are required for links with high PMD. We therefore repeated the loop experiments, but this time adding 40G RZ-DQ-PSK to the mix of 10G NRZ and 40G DPSK.
To summarize, our recirculating loop provides us with a unique capability to test our 40G transponders and wavelength selective switch products and to prove their interoperability in real system configurations.
Thank you for watching Finisar's recirculating loop demonstration. For further information, please contact Finisar.